So please give a hand to David.
Okay. Okay, so this is the third one of these in 10 days. For you Dutch audience, I saved the best until last. Actually, I gave a new talk on Tuesday in Vienna. And there was such a good reaction to that. People said, oh, just abandon what you're planning to talk about in Holland and do the Vienna talk. So I spent most of last night splicing the two talks into one. That means that some stuff got thrown out. Hopefully the less valuable material. So we'll see how we get on with this new talk here. It says lean risk management, options, liquidity, and hedging risk using Kanban systems. With the possible exception of Olaf, you'll not hear too many people in the Agile community use language like this. And then down there it says how Kanban's enabling a new approach to risk management and knowledge work. So let's see how we get on. First of all, how many people here are familiar with Kanban to start with? Most of you. Good. What that told me is that we've attracted the already knowledgeable audience here in the Netherlands. So we need to figure out our marketing for next year so that we attract new people. Okay, so a little bit of revision, which of course all of you are going to know all of this stuff already. Commitment in Kanban. When and where does that happen? So we have this little Kanban system here. And the commitment happens when we pull something from our backlog is the term that gets used in the Agile world. But backlog kind of implies that we've already agreed to do it. And actually, maybe we haven't. So when we pull something, I've called it the pool of ideas here. Pool with two O's. Very funny language, English. And when we do that, that is the point of commitment. And you see that I've marked this as the first point of commitment. And you'll see in a moment why I did that. Because what we're doing here is committing to starting something. What we're actually doing is taking the customer's order. Prior to that, we hadn't necessarily accepted we were going to do what the customer had put in our backlog. This was documented in the book, and it's been in the Kanban presentation since May 2007, but not very many people realize this. Kanban has a second phase of commitment when we actually commit to a specific delivery. And that happens sort of somewhere around here on the board, somewhere sort of downstream a little bit. Once we have a greater certainty of exactly when something will be delivered, perhaps we have some sort of regular deployment cadence. We do deployments every couple of weeks. And we want to know exactly which deployment a particular feature, function, user story will be delivered in. We don't commit to that right at the beginning. We wait until closer to the time. Of course, there may be special cases where the people doing the deployment or the customer taking delivery may need more warning. But generally speaking, we don't commit until closer to the time. The team I managed in 2007, we didn't commit to what was in Wednesday's release until the Friday prior to that Wednesday. So we have the second commitment point. So we're committing to specific delivery. So Kanban uses a two-phase commit mechanism. Right? That should be easy for most of you to remember. Right? Defining lead and cycle time, because I hear these terms misused and abused, and that they're generally confused. The clock starts ticking when we pull an item into the system. And for lead time, it ends when the item reaches the first infinite queue. Now, from time to time, you'll see Kanban systems, this is hard for me to do, where each one of these done columns here, it has an infinite in it, or more accurately, they only limit the work, the ongoing work. What that actually means is all these different columns are decoupled. They're all independent little mini Kanban systems. The clock stops ticking when we reach the infinite queue because it makes sense for Little's law and it makes cumulative flow diagrams correct, and I'll show you in a moment. So that's lead time. Cycle time, on the other hand, is an ambiguous term. When you just say cycle time, what does that really mean? A manufacturing industrial engineer working with a moving assembly line actually uses cycle time as the reciprocal of the delivery rate. So, for example, they might say the cycle time on a Toyota Corolla production line is 90 seconds. What that means is they're actually producing 40 Corollas an hour. That's clearly not what we mean here. Right? So, in this case, I've drawn the development cycle time. Right? It needs to be qualified with the bounds of what you're talking about. And this would be the end-to-end cycle time, which is from when we committed to the customer until we delivered something. This is a cumulative flow diagram. And what we've got in the blue area here is our pool of ideas, and what we've got in the purple area are things ready to deploy. And in between times, we started something and we moved it across the board, and then it reached our infinite queue here, waiting for the deployment process. So that horizontal distance is the average lead time. The height is the quantity of work in progress. And the slope here is our average delivery rate, and that gives us this equation, which is known as Little's law, and it appears in different formats. And I believe at least Donald Reinertson will have a different version of this equation, but it amounts to the same thing. So I like this term lead time because cycle time for many industrial engineers is the reciprocal of this, and that's confusing. This picture illustrates flow efficiency. What we're measuring here is how long does it take us to do something versus how much time did we actually spend working on it. Because as we move tickets across the board, they wait, we work on them, they wait again, we work on them, and so on. So of this lead time, how much of that time is actually waiting or working? And it turns out, so we calculate it this way: flow efficiency, work time divided by lead time times 100%. And when you first encounter a process, the numbers for this could be quite shocking. Zolt Fabok at our conference in Paris last week reported a 2% flow efficiency from a team he started working with in Budapest. Hakan Forsch, who's here in the audience somewhere, here he is. He's talked about encountering many clients for the first time where their flow efficiency is less than 5%. And my own experience is in the 5 to 15% range. This data also tells you why trying to estimate how long something's going to take is a very low leverage activity. Because when we ask developers, how long will it take you to work on this, or testers, how long will it take you to work on this, what they're estimating with usually reasonably inaccurate capability is the 5 to 15% part of the problem. But you know from this Little's law equation that it is the lead time that controls our delivery rate. So we care more about the lead time, and yet we ask our staff to estimate the 5 to 15% part of the problem because we don't estimate the waiting times. And I wouldn't recommend that you do either. Just study what actually happens. And this is a study of what actually happens. This is a lead time distribution graph. So On the x-axis here, we have lead times going up to 160 days. And on the y-axis, we have the quantity of work items completed. And from this, we can observe things like the average time things take. That would be our average lead time from the equation a minute ago. We can look at the different percentages here. So the 85th percentile, the first confidence interval in the data, the sort of 6 out of 7 times things will take less than this orange line, and 1/7 of the time they'll take longer. If our customer wanted to know exactly what amount of time could you guarantee, well, our 98th percentile here might be something like 105. This is real data from a team I managed. Rally Software have also published a lot of real data from their own development, and it's very similar to this. Averages of 2, 3 to 4 weeks, between sort of 10 and 25 working days, and tails on the distribution that go way out above 100 days. This is also multimodal data. And when you see multimodal data in a lead time distribution, it's telling you one of two things: that you have multiple types of work going through your system, and or you are offering multiple classes of service for those types of work. And if you were to filter based on that, you should get down to single mode distributions. So if we did that, we would end up with this. We'd have a distribution here and another one here. And this one is actually for fixing production defects, and this one is for change requests, which is new stuff. And this gives us additional information. We now understand the average time to fix defects and the average time to introduce new changes. And if we had a Kanban board now where we made lanes, one for the change request and one for the defects, and we set WIP limits on these lanes, so we have limits on the columns. Now we're going to allocate the capacity across those and have limits on the rows. What that will do is give us some dependability on, some consistent capacity allocation should give us some consistency on the distributions of these. So we should expect this distribution to remain reasonably similar from month to month. The tail might go in and out, but the peak here should stay roughly the same, and the average, which is what we care about, in my observation, will vary in the plus or minus 10 or 15% range. So if this is, say, 30, you could expect numbers in the range 27 to 33, which, if you go back to the Little's Law equation and you're trying to predict how fast are we going, that's good enough. Okay, that was the revision. Everyone knew all that stuff, right? Good. All right, risks and qualitative assessment. Some of this material is, for me, older than Kanban, and I'm not the only person to propose qualitative assessment or particular taxonomies for doing it. In the Agile community, Todd Little, who founded the Agile Conference in the United States, has published somewhat similar work. So has Neil Nicolaisen, one of his co-authors, on a book called Stand Back and Deliver. Recommended. Stand back and deliver. Anyway, so other people have thought about stuff like this, but this is how I see it relevant to Kanban. First of all, what's the key risk that we're actually managing? Well, it's what we're going to work on next. Here's our guy here, and he's idle right now. And the question in his head is, I could pick, actually this says 4, but I guess there's only 3. Actually, I know why there's 4, because we're going to replenish this. So actually it has 4 options. And I could pick any one of those 4, he says to himself. Which one should I pick? That's the core risk that you all manage. because what you want is for that decision to be the best possible decision it could be. And it doesn't matter where this guy works, whether he works here or whether he works over here, wherever he is in the process, at some point he finishes something. And then he says to himself, what should I work on next? And at that moment in time, he will have some choices available, assuming there's enough work in the system and some of it's queuing. We'll come to that later in the talk. And from the available choices to him, he should pick the best one. And if we always do that, we'll have a really successful business, right? So this is the core risk we have to manage. Sounds just too simple, doesn't it? All we need to do is make sure that the workers that work for us select the best things to work on next, and everything will be good. So, how does he go about doing this? Right? Maybe we need to give him some help. Right, because he's going to say, oh, I like yellow tickets. I'll pick one of those. Oh, but there's two of them. Which one should I pick? All right, so this pool selection. Right, now there's a special case of pool selection which happened here, which is system replenishment. Because system replenishment is us committing to actually delivering something. Right, we're going to do it. And then once we've committed to it, there's a set of work in the system. And at any given point, our workers who become idle need to pull things across. Now, a very simple system would be FIFO queuing, that we just pull things in order. We date stamp them as we bring them in here. And these workers are told, just pick the oldest one. Donald Reinertson, where are you? There he is. What's wrong with FIFO queuing, Don? Nothing wrong if you're doing homogeneous flow in manufacturing. What Don means is that if there is absolutely no uncertainty in your world, and you know the price and value of something in advance, and all the work is of the same size and complexity and difficulty and carries the same risk profile, then FIFO queuing will be just fine. Anyone doing software development that looks like that, everything's the same size and the same risks, the same complexity, the same level of difficulty, and all the work has the same value. So FIFO queuing doesn't work for us. We can say that as a general rule, that if you were going to FIFO queue, or let's say you have the circumstance where FIFO queuing is acceptable, and you do technology for a living, you're already out of business. No one's buying your completely uninnovative product. Or, in fact, what you're doing is pirating someone else's innovative product. Okay, so these are designed to be read, but I can talk. All right, so lean risk management uses qualitative assessment. We could do quantitative assessment, but I'm not a fan of that because I think it takes too long. Right, so how do we determine the risks in a work item that we must manage? Because we want to give our guy who's got 4 things to choose from a bit of help so he knows what to choose. Right, so we need a fast, cheap, accurate, consensus-forming approach to risk management. That's what I mean when I say lean risk management. Because we don't actually want to spend weeks, months, or years trying to figure out the risks and stuff and push them into our system with a myriad of information that just confuses our guy. So, when you're confused, you tend not to make decisions, right? You delay when you're confused. So, what we're looking for is a relatively small set of qualitative assessment methods, each of which has relatively small number of categories in its taxonomy. And here's one you'll be familiar with, maybe. In Kanban, we use cost of delay to assess how urgent something is and when we need to deliver it by. And in 2009, I started to introduce a qualitative way of assessing cost of delay. Because if I was to say, Janice, this feature, how much is it going to cost us? That sounds like I asked her for a quantitative assessment. How much is it going to cost if it was a month late? Right? I've been in real-world situations where a finance analyst has gone away and taken 3 weeks to answer that question just for one thing. Right? And then how accurate is the answer? That's another question. Right? On the other hand, with some executives who were Janice's bosses back at the time, I drew shapes on a flip chart like this. And I said, okay, we've got time on the x-axis and we've got impact on the y-axis. And the intersection of x and y is now. This shows the shape of the impact function in terms of how long it takes us to deliver. And they got this right away, that this one is a very steep rising line that says it's costing us a lot of money every minute or hour that goes by before we fix this. We have a severity 1 production defect in our website, and what we do for a living is sell stuff on the internet. And it's hurting us a lot. Or you can imagine perhaps workers in a production platform in the North Sea, and their pump breaks down. Right? So their ability to pump oil out of the North Sea ceases. Right? They measure that sort of number in sort of hundreds of thousands of euros an hour nowadays. Right? That's this shape here. On the other hand, what if in the very near future, and we don't get something done, we get fined by the government? This would be this unit step function here. These are expedite requests. We'll do them as soon as possible, and we'll drop everything to get them done. On the other hand, what if these same functions were delayed in time into the relatively near future, but perhaps far enough out that we'd at least have a probability of getting it done if we just gave it normal handling? Those would be fixed delivery date items. Then these that I called standard class items, they have this gently sloping S-curve that either starts immediately or at some point in the future. Some features are of a seasonal nature. We've dealt with firms in the clothing and apparel industry, for example, and they do software releases synchronized with their fashion releases. So when they launch the spring-summer collection, they also launched the new website for the spring-summer collection. Right? So early completion and delivery of the feature doesn't necessarily give them value. So it'd be more like this, where these tend to be cost-saving features. If we had this feature today, it would be saving us money tomorrow. Right? And then finally, this class I called intangible. Intangible are things that are really important, but are not urgent, like upgrading your SQL Server to 2010, which right now is something that might be on the minds of some of you. You haven't done it yet. Here we are at the end of 2012, but it's okay. As long as you get it done by the end of next year, probably won't hurt too much. What if you don't get your SQL Server 2005 upgraded to the 2010 edition by the end of next year? What is that doing to the rest of your environment? Martin Hoppin, I bet you know the answer. It's causing you lots of support issues. It's preventing you from upgrading other systems. It begins to hurt. So intangible items are things that are important to do, and if you don't do them, you'll end up expediting them later, but they're not urgent right now. Right? So we've got these 4 types, and you can show these shapes, and our experience was with the executives at this company in San Francisco back in 2009, they would all vote for the same shape, and they would agree on it within 1 or 2 minutes. with very, very occasional arguments about, certainly, I would say, less than 10% of the scope. All right, so understanding cost of delay enables us to know what to pull next. Right, that's one possibility. It's not always relevant because the cost of delay attaches to the thing you're going to deliver. Imagine if what you're delivering is a whole project and you're the guy who has to look at the tickets on the board, all called, say, user stories, and you have to decide which one to pick next. Cost of delay is not helping you with that immediate decision. Cost of delay helped your portfolio management team figure out which project to pick next. So maybe we need some other risk dimensions to help us. But first of all, introducing classes of service for cost of delay does help. In this case, I've used rows on the board to allocate the capacity for the different classes of service, for the different cost of delay types. And why does this make sense? Well, as we'll explain later, we use things like the intangibles to hedge against the risk of expediting or burst traffic in the fixed delivery date. If everything on our board was a fixed delivery date, how are we feeling? Feels risky, right? There's probably a good chance that we can't deliver all of those things on time. But if we manage to limit the fixed delivery date stuff and have some capacity for other things, we might have people that we could move around if we need to get stuff done. We'll also be able to observe different distribution curves for these things. Here are our expedites. There's a fixed delivery date. These are the standard ones. Right? So this allows us to have some confidence about when we should start things, right? When we should pull something into the system. It helps us with replenishment decisions. And here are intangibles, just for completeness. The cost of delay function is enough if what you're dealing with are things of more or less the same value or same other risks. But from time to time, it's not enough just to know the function, the shape of the function. You need to know the size of the function. How high does it go on the y-axis? And again, that might have the finance analyst scurrying off to his spreadsheet for another month to figure it out. On the other hand, I've come up with these 4 choices. The first one is called extinction level event. If we suffer this delay for a few days, weeks, or even a couple of months, we will cease to exist because we have expired the working capital of our company. And that sounds highly unlikely unless you're a startup, but it does happen to entire divisions of major companies. And my enterprise architect at the time that we were doing the early Kanban implementations is an Australian guy called Troy McGuinness. He went on to be a VP at Travelocity. And during his time there, they were closing down their hosting facility and moving it to another place, and they were changing vendors. And there was a very hard date for that, about a year in advance of where they were, middle of, I believe, 2010. And if they didn't get it done on time, Travelocity.com would go dark. How many days of darkness on Travelocity.com do you think that company could suffer before they would cease to exist? 0.001. I think a little more than that, but not very many is the answer. That would be an extinction level event for what's actually quite a well-known brand. And there's a really fascinating case study that Troy gives on how he managed that risk and delivered that project 6 days before they went dark. The next one down here I call working major capital, right? So in this case, it would be several years before we expire the working capital of the business. But it's enough that it will cause us to sacrifice a project from our portfolio for next year. In 2007, I was managing an ERP project that was due for delivery at the end of 2008. And in the summer of 2007, with all the fancy tracking that we do, we knew we would be 4 months late. So we asked, what's the cost of a 1-month delay? And our finance department went off and calculated that very quantitatively and came back with a number, $1.5 million. So we were forecasting a $6 million delay in an IT software development portfolio of about $16 or $17 million. So for the 2009 budget, we were looking at a $6 million deficit. Or let's call that the new website. Right, an entire project goes away. The next one down here is discretionary spending. That's more like departmental budgets, or just the company fails to hit its expectations and its numbers. And the last one is intangible, which is things like it would be terribly embarrassing for the chief financial officer. And we don't like it when she gets embarrassed because she gets very angry with us. This next classification I've come to call the market risk of change, because what it does is it identifies how likely is this requirement to change before we actually deploy it or deliver it to the customer. And there are 4 categories here. The lowest one is table stakes. Table stakes is something you need to enter the market. If you don't have this feature, you can't enter the market. So, for example, if you were in the mobile phone business, you need a voice calling capability. If you can't actually use it as a phone, you're not in the mobile phone business, right? You get the picture. SMS messaging would be table stakes, right? Nowadays, just the ability to do data would be table stakes. The top here is differentiators. Differentiators are new things that you're going to do that no one else does yet. That's why they're differentiating. And they might get the market excited, and you might get new customers, or your existing customers might pay more. The problem with differentiators are that they're an idea in somebody's head. And that is, to use the current trendy phrase, an invalidated, or it's an assumption that has not been validated in the market. These things are risky. Spoilers, on the other hand, that's copying. Oh, I apologize for this here. That should pop up later. Spoilers, on the other hand, that's copying somebody else's differentiator. And there's a life cycle here that somebody differentiates with a new feature, other people copy it, and once enough of them have copied it, the customer comes to believe it's table stakes. Right? Would you buy a car without a radio in it? Right? Because once upon a time, people did. And then a company that made two-way radios for the US military made a version of it that was one way that could go in a car. And they called it the Motorola, because it was like a jukebox inside your motor. How cool is that? And they renamed the company after it. Right? So once upon a time, a Motorola in your motor was a differentiator. Now it's absolutely table stakes, right? So the thing here is that table stakes are highly unlikely to change. Differentiators are highly likely to change. This gives us scheduling information. Things that are unlikely to change, we can start them early. Things that are highly likely to change should be delayed until the last responsible moment. They should be started late. Regulatory changes here, they should have popped up. They're a version of table stakes, but I've moved them up the stack. Why? If you're in a regulated industry, you cannot trade or do business unless you meet the regulations. But why have I moved them up the stack? Because the regulator changes the rules on you from time to time. Regulatory changes are subject to change, and therefore they carry more risk than table stakes. This is another one I call product lifecycle risk. This is sort of how new or how old and established is your product. And I've got 3 categories here. You could have more potentially. This is cash cow, this is major growth market, and this is innovative and new. Or you could use a scheme like the technology adoption curve thing that you see with Jeffrey Moore, sort of enthusiasts, early adopters, early majority, late majority, and laggards. You know, so if something is attracting laggards, it would already be here, and this would be your enthusiasts up here. What this is telling us is that things need different amounts of investment. And meanwhile, very well understood, low demand for innovation. These are low risk requirements. They're very unlikely to be wrong. So very low likelihood of rework, very high likelihood of rework, right, as we learn more information. In the middle here requires a high amount of investment, and at both ends of this, lower investment. That tells us about how we should allocate capacity in our Kanban system. So these are just useful examples, but they're examples I've developed over years working with real companies. And there's a theme with these. They use business language that business people understand. And what I'm proposing is that you continue to use that same language and you make that transparent through the whole system, that you visualize these real business risks. There is an underlying message here that doesn't come out in the slides, which is, forget this agile thing of calculating business value. Those are made-up numbers, right? Just figure out the business value for the user story. What that means is that the product owner goes and consults his crystal ball in the privacy of his cubicle. He keeps it in that low drawer, pulls it out, crystal ball, strokes it a bit. The crystal ball then tells him what it thinks the business value is going to be. The bottom line is people do not know this stuff. They make the numbers up. They might come up with infinitely plausible looking spreadsheets to justify them, but they're made up numbers. Oh, and then we go and ask the developers and the testers, how much will it cost? And we divide the made-up number by the very badly estimated number that only focuses on 5 to 15% of our lead time that's supposed to tell us how long it's going to take. And we use all of that to calculate return on investment, and then we stack rank everything, and there we've got our priorities, and now we know what order to pull things in. Stop doing that stuff. Not only does it not work, it's patently and obviously nonsense. I can see that from all the nodding heads, and then there's all the tribal agilists in the audience looking at me like this. Right? It's okay, you'll get over it. Right? So we can easily envisage other risks. So the market risk of change taxonomy, I used that with Janice's employer in 2009, and they looked at me and they said, David, we all understand this. We've all been to business school. We've all read Michael Porter. It makes total sense to us, but it will never work here. And I said, why not? And they said, well, this taxonomy is designed for an established market where there are competitors with established strategic positions. We are in such a new industry that we don't have competitors. And this was actually true. They were in the industry of making computer games for improving brain plasticity. And at that point in time, there was no one else making software for improving brain plasticity, at least not in that nature. Now they do have competitors, but back then they didn't. So my response to them was, okay, if my taxonomy doesn't work, what will work? And I came back the next day and they said, we've thought about it. We've come up with just 2 categories for us. There is existing customer demand, and there is innovative, new, experimental stuff. Just the 2 categories. So my next question was, bearing in mind that you're a privately funded San Francisco-based startup company, how much risk do you want to take? And I'm asking them to allocate the capacity of their available investment, which is basically their development team, how much of that team should be spent on existing customer demand versus innovative new experimental stuff. And they actually needed the cash flow from the existing customers. So they went 60% with existing customers and 40% with innovative new stuff. That would be 2 rows on your Kanban board, and you figure out what the WIP limits are to give you a 60-40 split. Right, so here's the general thing we're doing here. At one end of the scale, we could treat everything as homogeneous. Everything's a user story, all the risks are the same, FIFO queuing will be just fine, and we're done. We've made all our decisions. It's fast, it's cheap, but boy, is it high risk. We're not going to be in business too long, Don, if we take that view, right? On the other end of the scale, we could treat everything as heterogeneous because, after all, we're unique. We're all individuals, and all the work we do is unique and individual. And that drives us down this deterministic approach to management, and everything needs its own estimate. It's expensive, it's time-consuming, there's a lot of fake precision, there's a lot of crystal ball stroking and making up numbers. It's probably still high risk. Oh, and we've been trying it for 40 years, and we know it doesn't work very well, but we're still in denial. On the other hand, what we've got here is a middle ground that says, come up with a few dimensions of risk, come up with some taxonomy for those, between 2 and 6 categories, and then ask people, what is it? What's its cost of delay? What's the stage in the market development, and so on. And you'll find people can answer these questions very quickly. So it's cheap, it's fast, it's accurate, it drives consensus, and what it means is that you're managing the risks in the business appropriately. Was there something popped up there? No. So you can visualize these using these multi-dimensional diagrams that get known by different names. But what we have here is an axis for each risk dimension, and I've added another one called technical risk. And I've marked these out, unknown solution, known but not by us. We've done it before, it's a commodity. And I've got table stakes, cost reducer, spoiler, differentiator, cash cow, etc. The intangible, standard, fixed date, expedite. And I've drawn this in a very particular way, and then I've mapped on the profile for a project or a particular work item within a project. Things towards the outside should be started early. They're riskier. And in some ways, or not riskier in other ways, right? The expedite start early, whereas table stakes, actually not so risky, but you should start them early because they won't change. The things towards the inside should be started late. Right? In this case, the differentiators, because they're subject to change. So a picture like this gives us insight into when we should replenish something into our system. And items with the same shape carry the same risk profile. That means that if you've got 10 things with the same shape, as far as I'm concerned, just pick whichever one you like best. Don't bother trying to prioritize them because they're all the same priority. Pick whichever ones you like. You may end up discarding some of them eventually if you don't pick them. Right? That's basically what this says. Right? And it's also wise to hedge your risk by not filling your entire Kanban board with everything of the same shape at the same time. Right? It might be good to have some stuff that could be started later being done earlier. Right? So let's take a look at hedging. Okay, so you saw this before. This is hedging. The risk of expedite requests or seasonal spikes in demand for fixed delivery date by balancing capacity for standard and intangible. The more risk there is here, the more of these you need. The more intangibles you need, the more risk there is of, say, a spike in seasonal demand for fixed delivery date items, which is very common in regulated industries. This one has table stakes, cost reducers, spoilers, and differentiators. And generally, this capacity allocation should be aligned with a go-to-market strategy or a strategic position. I think what the pop-up here says is you can reduce the table stake demand by narrowing down your market. As you segment the market, the number of table stakes for any given segment will be less than the total. And that may enable you to do some differentiators. And why you would want to do that is if there's a risk of requiring early delivery, if there's a risk that the chief executive of your company walks in halfway through your project and says, I need to pick on him, Pavel, we need to release by the end of next month. What have you got for me? Everything he has. Are any of those really funky differentiators? Sounds like Pavel's only been building table stakes. And what that leaves me with is a terribly boring product, so I may as well not bother releasing early next month. Why do I want to release early? Because my competitor just released something and it's stealing all the mind share in the market. On the other hand, if Pavel had been ahead of the game, worked with the marketing people, narrowed down the segments a bit to reduce the table stakes, he could have freed up some capacity to build some differentiators early, even though there's a risk they might change. And when I come to him and say, Pavel, what have you got for me? He shows me some really exciting feature that I wasn't expecting yet. And I'm like, whoa, great, let's go to market next month. I apologize for the boringness of this diagram, but this is a portfolio. And what's happening here is that the tickets slide across as the project gets more complete. And we're dividing up the budget in the portfolio by cash cows, growth markets, innovative new stuff, and then allocating that to different projects, and they might have their own Kanban boards. In this case, the color may designate the cost of delay for the individual projects. So we're managing multiple dimensions of risk on the same diagram. Options. How much time have I got, Olaf? Oh, okay. Pool of ideas, I didn't call it backlog. And the reason for this is that some of these ideas get discarded. We reject them. Rather than pull them into the system, we reject them. The numbers for this are quite interesting. Last week in Paris, Dave Nicolette had a quote from, I believe it was a senior executive at UPS, who said that in 2003, half of their backlog had been discarded. The very first Kanban system in 2004 at Microsoft, 48% of their backlog got discarded. And in a discussion I had with Dawn, where we're walking around the streets of Paris last week, after seeing Dave Nicolette's numbers, Dawn said that he sees this quite often, right? That discard rate of 50% is not unusual. The thing here is that, as many of you will have heard from Olaf in the past, options have value because the future's uncertain. And the more uncertain your future, the more options you need to have so that you can discard them. Now, this just makes sense. If you're a startup company, you want like tons of ideas, and then you try to figure out which one of those ideas are actually worth building and taking to market. On the other hand, if you're in, say, a 300-year-old insurance company and you're still selling many of the same products you did over 100 years ago, maybe not so much. You don't need so many options. Right? So the discard rate, this 50% number, it's just a number that happens to have shown up a few times. There may be places that have discard rates of 80 or 90%, and there could be other places that have discard rates of almost zero. Platform replacement at parity, for example. If you're listing all the features in your legacy platform, how many of them are you going to discard? Maybe not so many, right? Bottlenecks should always be downstream from the commitment point. Here's our commitment point. And what that means is that our bottleneck should be here. Or put another way, the people that come up with the ideas need to have slack capacity. We actually need more ideas than we can work, and the bottleneck should be downstream. Why is this? Well, because we want to exploit our bottleneck workers to the full to maximize the throughput we get, the number of things we get delivered. And that means that bottleneck workers should never be asked to work on something that's optional. They should never be asked to work on something that's speculative. They should never be interrupted to make an estimate for next year's project portfolio. Because what you've done is you've reduced the capability of your entire system by asking your constraining factor to waste its time on something optional. This creates an interesting set of competing forces, right? Those of you that are familiar with Lean will know this term, the last responsible moment. The last responsible moment says that you should commit as late as possible. So as late as possible would be sort of over here somewhere. Right? So last responsible moment, I apologize for the sky getting in the way here, is pushing the commitment point this way. And you see that I've moved it beyond the analysts here. We're only going to commit. And what development, that's telling us that we believe that development or testing is our bottleneck and that our analysts have slack capacity. On the other hand, bottleneck theory, if you read into this, will tell you that you should push the bottleneck as early in the life cycle as possible. So if we think development's our bottleneck, actually we should try to change, we should probably fire some of our analysts to make them the bottleneck. Right? That would push the bottleneck this way. And we like that for all sorts of system dynamic reasons, some of which I've heard from Stephen Parry and Don Reinertson in their talks over the last week. And I don't have time to get into. But the essence of it is if your bottleneck's way upstream, all your downstream stuff is slack capacity and all the variability gets absorbed between your commitment point and your bottleneck, and then downstream of that, everything flows really smoothly. Beautiful. Except for the fact that it means you're committing early. So, right, in domains of high uncertainty, the bottleneck should be deliberately late in the workflow. And I'd therefore like you to consider the lean startup concept. Where is the bottleneck there? It's not in our system at all. Right? Because the concept with lean startup is everything is still optional until we've validated it in the market. And then we decide whether to amplify it or dull it down or discard it completely. Right? Everything's an option when the world's really uncertain. This should give you an indication of where the appropriateness of the lean startup guidance is. Or as one of my IT Agile friends in Germany recently submitted a talk with the title, "You're not doing lean startup, you're doing experimentation." Right? Because to really be doing lean startup, that says you're in a world where things are so uncertain, you're not committing on anything until you've actually put it in the market. If you don't have that level of uncertainty, you're just experimenting. You're finding ways of validating ideas a little earlier. The optimal exercise point, this is a concept in real option theory. How do we do it? And the team that I managed in 2007 came up with this without even knowing what real option theory was. So the problem would be, if you've got a fixed delivery date item, when should you start it? When's the best time to start it? Even with standard features in this example, right? This is when we need it. This is when the cost of delay starts to be incurred. If we have a distribution graph that looks like this with our 85th percentile here, then we want to hit this, sort of lining. So backing up to here, that would tell us that we have to start the item here, and we have a 6 out of 7 time chance of finishing it before we need it. What do we do if it's 1 in 7? What do we do if it's on this end of the distribution and it's going to be late? We expedite it, right? We have the option to promote its class of service. So picking something like the 85th percentile and backing out from that, that's the point of replenishment. That's how you do the optimal exercise point. So why is this important? Well, if we started something earlier than the optimal exercise point, we forego the opportunity to do something else that might be more valuable sooner. And if we go beyond the optimal exercise point, we start carrying too much risk. We may end up having to expedite things regardless. Liquidity, this is what at least the people who are in Vienna all want to hear again. Right? Investment bankers have an answer for where's the best place to place an order for an investment. The answer is the most liquid market. So there's this question of who would be the best software development team or organization for us to place our order for a new piece of software? Should we give it to Pavel in the Poland office? Should we send it to Arne in the Hamburg office? Or should we build it at home? Right? Questions like that need to be answered. Well, investors will tell you that they place their order in the most liquid market. And what does liquidity mean? Okay, this is a liquidity explanation for a housing market. What we're trying to do is match buyers and sellers. And we have here some people trying to sell yellow, green, and blue houses because they're yellow, green, and blue people. And then we have some buyers who are also yellow, blue, and red. And we can match our yellow buyers with our yellow sellers. And in this case, this yellow buyer, he doesn't have enough money, but he has a bank who's willing to lend it to him. So we're all good. We have liquidity in the market. In this case, we have a cash buyer. That's very easy. And then we have a blue buyer here. So when we have matched buyers and sellers, houses are being sold. That's a liquid housing market. Adverse conditions would be things like, so measuring liquidity, is basically measured as the number of transactions in the market. The more houses being sold, the more liquid the market is. What if there's adverse conditions? So in this case, we don't have enough sellers. There is a shortage of sellers. There are lots of buyers. Well, what happens in this sort of market is that the seller becomes uncertain of what would be a good price because they think, oh, if I just waited a bit longer, there might be another buyer who'll pay a higher price. And in the English housing market, they have a word for this, a verb. It's called gazumping, which is where Janice might agree to buy my house, but I think, ooh, if I just delay a bit, there might be another person who'll come along. And so I delay the paperwork for 2-3 weeks, perhaps. And during that time period, someone else comes along with more money, Stephen Parry. And he bids more on the house, and I tear up the paperwork and I say, sorry, Janice, you're stuffed. That's gazumping. You notice that delays the transaction, and therefore the transaction volume falls. Right? This is a case where we have lots of sellers but very few buyers. Right? And in this case, the uncertainty will develop over the correct price because, again, the buyer doesn't want to pay too much. They don't want to buy something when they might find a cheaper deal somewhere else, so they delay making a decision. So transaction volume falls. Right, so market liquidity is measured as the rate of transactions. And what that really means is we need a well-matched and balanced set of buyers and sellers. So how would we measure liquidity in a Kanban system? Well, if we recall, liquidity is measured as transaction volume in the market. So what are the transactions in the Kanban system? So here we have a buyer and here we have a seller, and there's no match. Right? Here's a guy saying, what should I work on next? Oh, I've only got one choice. Oh, I don't have the skills to do that piece of work. I guess I'll just have to go onto Facebook. Right? On the other hand here, what I've done is I've increased the WIP limits, I've increased the workforce, and I've got some multi-talented people in the workforce. And now we've got matches here. So these guys, red worker can pull a red ticket and a yellow worker can pull a yellow ticket. Maybe this is not, but we've got transactions happening. By increasing the WIP in the system, by increasing the workforce, by increasing their skills, I have improved the liquidity in the system, right? That pool transactions will happen now. So the message here is more WIP increases the liquidity and increases the flow, but it also increases the cost. So we get more transactions, the market's more liquid. We might want to be able to normalize our assessment across different suppliers, because we want to know if those Polish guys are definitely cheaper than the German guys are actually offering us a good deal or not. Well, we could do that by normalizing the number of pool transactions per person if we're in the same currency zone, or by unit of currency. And that would allow us to assess the cost we spend to get a single pool transaction. That's anywhere in the system, any amount of movement in the system. All right, great. I can skip that. Characteristics of liquid markets. Finance people will tell you that a market has a concept of tightness, the difference between the bid and the ask price for a particular item, or the spread. They will refer to that. Immediacy is how quick can we fulfill an order. Breadth is ability to handle large orders or very small orders. You know, from retail investors who want just a few shares of something to institutional investors who want to buy like 20% of the company. Can your market handle that variation in volume? Depth is processing orders at different prices, and resiliency is the ability to bounce back after something freaky happens. Like, say, Google accidentally releases its numbers before they were meant to. So what would the Kanban equivalent be? Well, tightness, I'm not sure, because, as I said here, we don't have a market maker, at least not yet. There's no one in the middle. Or maybe this is a new role for the product owner. He could be the market maker, and he can take bids from marketing people with ideas, and then he can place, orders. I am joking here. I can see a few faces going, is he serious? I don't know if tightness has a meaning, but immediacy is the time to make the pool happen. The breadth in the market is number of types of work. If you've read chapter 6 in the Kanban book, you'll know that one of the things I define as a type is the order of magnitude in size. So it could be everything like projects and large features down to very small user stories. But there are other types of work based on the source of the demand or the destination for the demand and so on. The depth is, in my opinion, the number of risks under management, the number of dimensions, those risk dimensions in the risk profile. And resiliency is the same thing, the ability to recover from, say, a large spike in demand for fixed delivery date items because you work in a regulated industry and the regulator dumps a great big book on you. So if we could observe the liquidity and we can observe things like the delivery times, we can then decide how reliable a vendor is. Pavel might be offering us a cheaper price. He might be faster, but maybe his team doesn't have the same liquidity that Arnie's team has in Hamburg, and I'd rather pay more for a bit of German precision. Why is liquidity a good metric? Don Reinertson had this criteria for good metrics. They need to be simple, self-generating, relevant, and leading. And liquidity is all of these things, right? Simple, because we know the pool transactions, we're tracking them electronically. It's self-generating, we're tracking them electronically. It's relevant because it helps us understand the risk we're managing. High liquidity will have tighter distributions. That's the core thing. And it's a leading indicator because, some smart people who were in Vienna twittered to me the other day and said, couldn't you just use the lead time distribution? Well, yes, you could, but it's a lagging indicator, right? Liquidity is a leading indicator. It helps tell us things that are happening. It's also a global system measure, which makes me believe that it won't have nasty side effects for local optimization. Right. I talked about the relevancy here. I'm kind of out of time. This last thing is important. One more slide here. How could we improve liquidity? Well, here's one example. This team has 4 lanes for different types of work, and we have teams here that are assigned, and we have, in bold, Joe, and then David, Peter, so on. 2 people in each team, permanently assigned. And then we have these other guys. They have little avatars on the board. So we've got permanently assigned people, and we've got floating people. We've also got team leads, and we've got junior people. And the team leads are responsible for each of these lanes and the delivery and the capability. These junior people are going to be rotated from one team to another over a period of time. And once they've done that for long enough, then they're going to get promoted to become one of these generalist workers or T-shaped people because they're sort of specialist in one area, but they can generally work anywhere. And they're more flexible, and we can move them around on a daily basis to keep work flowing. What that does is it tells us why we should give that person a pay rise, because they help us manage risk better, because they make the system more liquid. Right? Promotion from junior to flexible worker justifies the pay rise. So, conclusions. Kanban systems enable us to visualize many dimensions of real risk. You'll need to decide which ones are relevant for you in your context. Hedging risks possible with capacity allocation. It's also very visible how we're doing it. Kanban is enabling practical application of real option theory and related concepts like real liquidity. Qualitative approach to risk assessment is fast, cheap, and it drives consensus. There's no crystal ball gazing. Everything you're getting from that is real facts. No one's speculating about the future. Right? So this is the core message. Stop speculating about the future. Stop stroking your crystal balls. And trying to imagine that there's some business value number as if it's real, and then using that real number in all sorts of equations and evaluations in order to justify sequencing and prioritization. Use real business risks, visualize them, hedge them with capacity allocation, understand the liquidity in the system, and practically apply some option theory based on the amount of uncertainty you're facing in your world. And that was 2 keynote presentations rolled into one. Thank you.